Okay, so we understand that the GPS is transmitting a carrier wave. That's an electromagnetic wave. We understand where its frequency is. And we understand that it's being modulated to carry a code. So let's talk about the code that's actually carried by the carrier wave. And the code that we use is referred to as a coarse acquisition code, or CA code. And this is part of what's referred to as the standard positioning service, which is the general legacy. It's often referred to as civilian service. So this is what we're using, the coarse acquisition code. There's also another code that is modulated on the signal that is called the precise code, and this is the military code. Then this is part of a precise positioning system, and it's the PY code, and we'll talk a little bit more about that in just a minute. So both of these codes are what are called pseudo-random noise codes, or PRN codes. And basically what is kind of illustrated down here is a series of ones and zeros. It's a binary code, so it's a binary, meaning it's either 1 or 0. And it's a complicated but repeated pattern, and both the CA code and the PY code are both pseudo-random noise codes. There's a different PRN code, a different sequence of ones and zeros for each satellite, for each space vehicle, for SV. And the GPS satellites are actually identified by which PRN code they're transmitting. So when you pull up your Garmin and it gives you your little satellite map and the satellite numbers show up, that number is actually associated with the PRN code that the satellite is broadcasting. So one satellite in its lifetime may change numbers because it may broadcast different PRN codes. And a single PRN code or satellite or number might apply to different satellites as satellites broadcast different codes. And that number is actually referring to which week of the PY code that the satellite broadcasts. So the PY code is actually this really long sequence of ones and zeros, and it's many weeks worth of ones and zeros, and each satellite broadcasts a week of it, and that PRN number is associated with the week of the PY code. Okay. So let's talk more about that CA code, the one that we use, the coarse acquisition code. It is a stream of over 1,000 digits, binary digits, or ones and zeros. It repeats every millisecond. So every second, 1,000,000 digits are generated. So this is a lot of information happening really fast. And so if we take into account how fast the signal is transmitted at the speed of light, the length of one chip can be calculated to be 300 meters. There are 37 CA codes defined, 32 in use at any given time because we have 32 satellites. So each satellite has a unique CA code, and the satellites, like I said, are identified by that number. And these are civilian use, and this is the code that we're using when we use a Garmin or the Trimble mapping grade receivers that we will use in class, are all taking advantage of the CA code to calculate their position. The PY code, which we aren't using, is the precise code. It's this very long sequence of binary digits, so it's also a pseudo-random noise code. It repeats every 266 days. It has 38 segments, each 1 week long, and that's where that number comes from. So each satellite transmits a unique 1 week segment of the P code. And a CA code and a P code are combined together. And if a satellite is transmitting a CA code, it transmits the P code that goes with it. So those are inseparable. And in 1994, the U.S. military began encrypting the P code with the Y code, which makes it more difficult to mess with the signal, and it encrypts it. All right. Also being carried on the carrier wave is another message which carries a lot of other data with it. And that is referred to as the navigation message. And what it includes is information about the satellite timing and the synchronization of the signals. It includes very precise orbital data, which is referred to as ephemeris data. So this is another term you want to make sure you remember. Ephemeris is referring to the orbit of the satellite. So this navigation message is telling your GPS receiver where the satellite should be. It includes any kind of time correction information to determine the exact satellite time, and it includes orbital data for all of the satellites. It includes any correctional signals that it knows on, data of the ionosphere. Not all GPS receivers can take advantage of ionospheric data, but some can, and information about the operating status, the health of the satellites. And so your receiver then is going to use this navigation message and determine the transmission time of each satellite signal, and knowing the exact position of the satellite and the time delay, then it can calculate the distance of the satellite, and then using the location of the satellite, figure out where the GPS receiver is. So to give you an idea of what this looks like, I know this is a complicated diagram. So let's start at the top. Here's our navigation message. So some data, about 50 bits of information per second, and it's binary data, zeros and ones. So that's our navigation message, our data. Here's our CA code, which is 1,000 bits per second. And it's, again, a series of ones and zeros. So then what they do is they modulate the data with the CA code. So now what we've done is we've modulated this data code here using this sequence of ones and zeros. And now we've got the data sequence that we want to apply to the carrier wave. Here's our carrier wave, our sine wave that has a frequency of 1,575,420 hertz, or that many over a million cycles per second, right? And what we're going to do is we're going to take this data series and use that biphase modulation to adjust our carrier wave. And this is what we end up with. So you can see every time we switch from 0 to 1, the phase of the carrier wave switches. So that's what's going on behind the scenes, and that's how your GPS receiver gets the information from the satellite. I know this is a little crazy diagram, so just bear with me. Here's our L1 carrier wave, which is the one we use. Here's the L2 carrier wave, which is carrying the military. It's what the military uses, and some dual frequency receivers. Here's our CA code. Here's our navigation data, and here's our P code. Okay, so the CA code, course acquisition code, standard positioning service, this is what we're using. It, along with the nav data and the P code, are modulated on top of the L1 carrier wave. The L2 carrier wave is just getting the nav data and the P code, and that goes on the L2 carrier wave. All right. So as the GPS satellites are being modernized, they're beginning to carry or to send some new carrier waves and some new codes. And the 2F, which that's the satellite that we watched the launch of in July of 2015, was a Block 2F satellite, and it is now broadcasting the L5 carrier wave. And also the 2RM, which are the ones prior to the 2F, are also including civilian codes on the L2 carrier wave. So there are some new things coming about with the new satellites. The GPS receivers we have aren't able to take advantage of that. So we're using the L1 carrier wave that's been modulated with the course acquisition code, or CA code.